Since I flew back from Arizona. How musty is this mask? Okay. So we are finishing 7B solving trig equations today. Let me see if my pen is going to work. Make sure you have out your unit circle sheet, okay? Oh, I know, the warm-up I was going to do today, we're still focusing mainly on this one. We're also going to do some today that involve trig traits. Yesterday when we went over these, it was not real clear what a defined interval or open domain meant. Does anybody feel any better about that today? That when you are solving equations over a defined interval usually means like 0 to 2 pi, okay? And that means you don't need the plus or minus 2 pi n, remember that? And if it says over an open domain, that's when you need the plus or minus 2 pi n, as long as you give me every solution that's on your unit circle and then throw that on the back. All right, this is what I was thinking today. If anybody wants to, you don't get to use this unit circle on your quiz anyway. So if anybody wants to write the tangents next to them, that might help make the homework go faster. Do you know what I'm saying? So it's totally up to you. But remember, I'm going to talk through these. Tangent is y over x. So this one is 1 over square root of 3, which would normally reduce to square root of 3 over 3. And pi over 4 is square root of 2 over square root of 2. So the tangent's 1. And at pi over 3, it's square root of 3 over 1, which would just be square root of 3. Up top, it's 1 over 0, which is undefined. Then you have the same ones, square root of 3, 1, and square root of 3 over 3 again, but they're all negative in this quadrant. And then down here, because it's negative over negative, you're back to positives. And then in this quadrant, it's negative over positive, so you're back to negatives. I don't know if that helped with homework, but that won't be on the quiz that way. So do you know them, that you could write them if you needed them? Okay. How we got them and everything. Nobody has a question about how we got those. It's just y over x. All right. Whoops. Did you get done what you needed? Anybody need more time? Okay. Oh, that's a good question. No, I missed this one. 0. What's 0 over 1? 0. Yep. The tangent there is 0. Sorry, I put the one at pi, but I forgot that one. All right. This was Delta Math last night, and I did not, in your class, remember to do an example like this. Did anybody have trouble, or did you just watch look at their example? If you solve this, let's see, if we add a 2 over to the other side, and then we divide by a square root of 2. And what does secant mean, guys? Yeah, it's the flip of cosine. So if we flip this both sides over, we'll have the cosine is square root of 2 over 2. Does that seem okay? Everybody all right? So that's all you had to do on those weird ones, is flip this over and it will become cosine, flip this over and it'll become square root of 2 over 2. And then I think that happens at pi over 4. And the other place it's positive would be 7 pi over 4. Is that right? Somebody check in for me that the cosine is a positive square root of 2 over 2. Okay. And those are the two answers you would have needed to put in. And everybody knows how to put two answers into Delta Math. There's either the little plus, or I always just put a comma. Did you know you can type PI and it'll change it to a pi symbol right away? I don't ever click on their little pi thing because I hate using the mouse. If I don't have to, I just type PI and it pops up to a pi. Just a hint. I love that feature. All right. This one, I actually did this question, I think yesterday, on an example one, but if you add 1 over to the other side and then you divide by 4, you get this, and you just can square root both sides. And square root of 1 is 1, square root of 4 is 2, but what's the biggie? You got to remember plus or minus. So there's actually 4 places that would be true. Everybody okay with that? Everywhere that the sign is either positive 1/2 or negative 1/2. I won't go through them all. Are we good? So this one again would just be 2 over square root of 3. But then if you flip cosecant over, you get what? So you're looking for where the sign is square root of 3 over 2. And you'd put in those two answers. I just wanted to make sure everybody was okay with that kind. That was my warm-up today. All right. On the back of 7B, or on 7B, since there's no front and back to any of these, you can use trig identities along with algebraic methods to solve trig equations. Be careful to check your solutions. I am not going to give you one on a quiz where you have to worry about checking your solutions. Okay. I think, yes, in this class, I did this one yesterday. I'm just going to fly through real fast the trade. Somebody remind me, we had a tangent. If there's a function that's not squared, you can't get rid of it. So that's what you need to put everything else in terms of. What did we trade secant squared for? Real quick, was it a 1? Anybody got it on their sheet in front of them? Secant squared is a tangent squared plus 1. So we had 2 tan squared minus a tangent squared plus 1 plus 3 equals 1 minus 2 tangent of x. And then we did some distributing of the negative. Okay, then I'm going to add these two over here. Whoops, this was a squared. Okay, I'm going to combine these two, and that gives me a 1 tangent squared. Then I'm going to add these 2 tangents over here. I'm going to subtract this 1 over here. Negative 1 is negative 2, plus 3 is positive 1. And that leaves me nothing over there. Then it factored tan of x plus 1 times tan of x plus 1 equals 0. So we had the tangent of x equals negative 1. How am I doing so far? Okay, so the directions nicely said just 0 to 2 pi. So can you find where the tangent is negative 1? We just labeled our unit circles to make it easier. I'm thinking 3 pi over 4 and 7 pi over 4. Is that where it's negative? Okay. And why don't I need a plus or minus anything? Because we didn't square anything. Meant we didn't need the, yeah, that was a good answer. But here what I'm thinking, what I meant to ask was, why don't I need a plus or minus 2 pi n? Yeah, it just says 0 to 2 pi. Everybody okay with that? All right. So this example 2 that's in your notes, they squared both sides, and then at the end they had to double check if they worked. I'm not going to put one on a quiz where you have to square both sides, so is it okay if we just skip that example? We are going to talk through one that's kind of weird, but all right, so this one we would just square root number 9. I should have asked you, but yes, we're going to square root both sides. When we square root both sides, though, we have to remember that we get the tangent of x equals, what's the square root of 1? 1, but it is plus or minus. So I need all 4 places that the tangent is 1 on the unit circle or negative 1. So I'm thinking pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Did I hit them all? Now, there's a much easier way to write that, because what is the period of tangent? Does anybody remember when we graphed tangent? It only has a period of pi. So you could have said pi over 4 and the 1 straight across from it, and 3 pi over 4 and the 1 straight across from it. I would not count it wrong. It does say all values if you put plus or minus 2 pi n on the back of all of those, okay? But you could have also said positive or negative pi over 4 plus or minus pi n, and that would be the shortest way to write it, because it's saying you go this way to pi over 4 or this way to pi over 4. and then you go straight across and you'll hit the same answers. So that's one that it really would make it a lot easier to write it that way. But if you wrote that all the way down for all 4 of those, I'd take it. Okay. Number 10, this is where we have to do a trade. Does anybody remember what I said a minute ago? When you have a plain function without a squared, you can't get rid of it, okay? So how could I get rid of a sine squared so that everything only had cosines? This is on the quiz, guys. Eventually this kind is on the quiz. I don't think it's on this first quiz, but what are we going to put in place of a sine squared? Because we can't get rid of cosine. We need cosines instead of sines. Sine squared is it 1 minus cosine squared? Everybody okay with that? It was sine squared plus cosine squared equals 1. So if we wanted the sine squared by itself, we would subtract the cosine squared over here. All right, then what? Next 2 steps are to distribute, and before we can factor, it has to equal 0. So if I distribute, I get 2 minus 2 cosine squared of x minus the cosine of x. I could subtract the 1 over to this side, I guess. I'm not really liking this because I don't like when there's a negative on the square. Does everybody? So we could move everything back to the other side, or we could just change all the signs. I guess I'll just write it and then change all the signs. So we have a negative 2 cosine squared of x. We have a negative 1 cosine of x. I got to combine these guys though. 2 and a minus 1 is a positive 1. Whew. A lot of room to make a little mistake on that guy, right? Then what? Because I don't like negative in front, I'm going to change everything. So I just chose to multiply all the way through basically by a negative 1 because I don't like the signs. As long as you do it to both sides, you're golden. Anybody know how that factors? If this really freaks you out to factor these, take the word cosine out. Just pretend it says 2x squared plus x minus 1 and figure out how to factor that. So it would be a 2x and a 1x. And to get a 1, you need a 1 and a 1. How are we going to get a positive 1 in the middle? Anybody know how the signs are going to go? I'll make them both negative for a minute. Which one do we want to be positive? This is a 2x minus 1x. Do we want the 2x to be positive? So we get a positive 2x minus 1x gives us the 1x in the middle. All right, so 2 cosine of x minus 1 and a cosine of x plus 1. Okay, if we set those each equal to 0, can you solve that in your head? What isolating the cosine here would make it equal to? Yeah, if we add the 1 over, divide by 2, we get 1/2. Is that okay with everybody? I'm running out of room. I don't know about you. Here we get the cosine would equal negative 1. Was this all solutions or just 0 to 2 pi? Oh, lovely. All solutions. Okay. Where's the cosine 1/2? Guys, that means a 1/2 in the x spot on our unit circle. Cosine is 1/2 pi over 3. Am I right? And 5 pi over 3. Thank you. And those both get a plus or minus 2 pi n because it said all solutions. And the cosine is negative 1 is also in the x spot, and that is just pi, plus or minus 2 pi n. Okay, how did we know what trade we needed to make? That was the big thing that would throw some of you off, other than simple algebra mistakes along the way. But because there was a cosine that wasn't squared, and a sine that was squared, we needed to get the squared term replaced with some identity so that we only had cosines. All right, number 11 is just weird. They talk about like how you could replace things, square both sides, do some crazy things. But can you just look at the unit circle, guys? Where are the sines and cosines the same? Pi over 4. Anywhere else that they're exactly the same? That seems like it, right? If you were to graph, and we will eventually talk about these on the calculator, but today I'd really rather review them by hand. Do you remember what the sine goes through the origin, right? And it finishes by 2 pi. We really don't need the negative because it says in the direction 0 to 2 pi. Should have not drawn that. Okay, what does cosine do? Starts up here and it goes midline, min, midline back to max. I'm just trying to make it cross at the right places here. Okay, so where are they equal? Right there and right there, yes? Okay, well, this was pi over 2. This was pi. This was 3 pi over 2. So what's halfway between 0 and pi over 2? Pi over 4. And halfway between pi and 3 pi over 2 was a 5 pi over 4. If you look at your unit circle, does it make sense that there was 2 places they crossed? Okay. We're not going to worry about checking this one by graphing, but what can we do here? I don't think we've done one like this yet today. Do you remember what we do? We did a bunch of these yesterday. All of this is multiplied together, and then this is subtracted. Factor out a cosine of x. It'll say cosine of x times, can somebody help me? What goes in the parenthesis? If I factor out the cosine here, there's still a square root of 3 and a tangent of x. Everybody okay out of that term? And then minus, when I take it out here, I'll get a 1. All right. Then we can do the take your turn being equal to 0 thing. We have the cosine of x equals 1. This one's a little nasty looking. I'm going to move the 1 over to the other side in the same step. Is that okay? So you set that equal to 0, add the 1, divide by square root of 3. Some of you would recognize that as a place where the y over the x is a 1 over the square root of 3. Does that make sense? Otherwise, if you rationalized it, this is square root of 3 over 3, and that's what we wrote on our unit circle somewhere. Okay. Oh, yay! Only 0 to 2 pi. That excites me. Cosine is 1, means we're looking for a 1 here, and that happens one place, right? At pi over, no, x value of 1. At 0. How do we know whether we call it 0 or 2 pi? Yes. That's a great question. Anybody going to fix me? Thanks, Paige. I don't know where I got that 1. What should that be equal to, guys? Phew. Thank you for fixing it, because otherwise I'd have to redo the whole video. Take your turn being equal to 0, not take your turn being equal to 1. So cosine is 0. That actually happens 2 places, doesn't it? So that happens at pi over 2 and 3 pi over 2. Is that better? Oh, and we don't have to put anything on the back because it said 0 to 2 pi. By the way, we always call it 0 because of the bracket, and we never call it 2 pi if we're including that. That's the thought I was halfway through when Paige fixed me. All right, and then where was this true, guys? That the tangent was square root of 3 over 3, or we had a point like this, or they could be both negative, so there should be 2 of them, I think. Pi over 6 and 7 pi over 6, is that right? Because if they were both negative, it would also turn out positive. Okay, so badly done, but there are my 4 answers. Phew, was that the last one on that page? Okay, let's go to 8A. This is your homework. Oh, here, I should go back. It says your homework is to finish 8A, okay? It should say 8A. But I'm going to switch over there. Now, do we need to do one of these? I can do either one of 1 or 2. What's the idea here? Let's talk about 2 because it looks really disgusting. I'm not looking like that's going to find anything on my unit circle. But actually, what can we do? Okay, guys, pretend that said x. 5x plus square root of 12 equals x. What would you do first? Get all the x's on one side? So maybe we could subtract the cosine of t over here. What does that leave? 4 cosines of t plus the square root of 12 equals 0. Now we still got to isolate. Okay, if we subtracted an x up here, we'd have 4x plus square root of 12 equals 0. Somehow you got to get the x by itself or the cosine of t by itself. Can I subtract the square root of 12 over to the other side and then divide everything by 4? I don't know how much room you have, sorry. But we got to do something with that mess. What is that? Ben, I really wish that you weren't on your phone. 4 times 3 over 4. What's that going to reduce to? Right? Everybody with me? Square root of 12 is square root of 4 times square root of 3. Square root of 4 reduces to 2. And what can we do with that 2 and the 4 down there? Yeah, reduce those. So we end up with a negative square root of 3 over 2. Until I tell you to pull out the calculator, and we're going to do some decimal ones, they should all be something that's on your unit circle somewhere, okay? So if it's not, something went wrong. All right, where is that true? This says, oh, yay, only 0 to 2 pi. So the cosine is negative square root of 3 over 2. Let me think about this. 5 pi over 6 and 7 pi over 6, is that right or not? Okay, 3 or 4. Do I need to do either one of those with you? I'm offering. Do 3. Okay. What do you want to do first? Add the 2 signs over here. We can. Or we could have gone the other direction. It doesn't matter. So now we have 5 sine t plus 5 equals 0. Then what? If we solve for the sine of t, we'd have to subtract the 5 over there and then divide by that 5. So it would become negative 1. Did I do too many steps in my head? So where is the sine of negative 1? Doesn't that only happen once, maybe? 3 pi over 2? And the directions are still just 0 to 2 pi, aren't they? Okay. This is one you're going to want to flip over, right? Tell me what it would say if I got the cotangent all by itself. I'm not going to actually finish this one, but if I add 1 over to the other side and divide by square root of 3, I get this. But if I flip it over, what is the flip of cotangent? Tangent. And when I flip this side over, I get square root of 3 over 1. Can you find those 2 places? I'm not going to put them up here, but tangent is square root of 3. And be careful, there's one straight across from it, right? where it was a negative over a negative, so it became a positive? Like 4 pi over 3? Yeah, that might be right. All right. Did it, you mean because tangent has a period of pi, but it wants all answers between 0 and 2 pi. So if I were to graph this, that's a great question. Here's what the graph looks like, and pi, let's see, this is 0, this is pi. Is that right? Tangent pi over 2 pi. Now I'm confusing myself. Oh, it said to go to 2 pi. Oh, so this is pi, and then it would do another one. This would be 2 pi. Okay, so when they say it does have a period of pi, but it does hit that value of square root of 3, which is like 1.7, 2 times, once before pi and once after pi. So by 2 pi, it does hit it twice. I confused myself there for a minute. I'm like, why would it have 2 answers? Because it said to go to 2 pi. Woo! All right. You want to just write yourself a note? What are you going to do first on this one? Yeah, you're going to have sine x something, okay? What about number 6? Any ideas on number 6? It's all cosines. So we for a minute pretend it just said 2x squared plus 7x minus 4. What would you do? Yeah, you'd have a 2x and a x. And what else might you do to get a 7 in the middle? Maybe 4 here, because that would be 8. And a minus 1, does that work? 8 minus 1 is 7. Okay, so it's going to be 2 cosine of x, not squared anymore, minus 1, and cosine of x plus 4. Do we need to finish that one? I'll just remind you that what happens here? Cosine of x equals negative 4. Is that ever true? Cosine can't be above 1 or below negative 1. I guess we can finish this one because the directions, this would solve to be cosine of x equals 1/2. Everybody okay? I skipped some steps. So we're looking for where the cosine is 1/2, but it says all solutions this time from negative infinity to infinity. So we have to put the plus or minus 2 pi n on the back. Did I do something wrong? Everybody okay? Okay, I just was confused. Cosine is 1/2. That would be pi over 3 and quadrant 4, so 5 pi over 3. Is that right? Okay. So this one you're going to do 2 parentheses. This one you're going to take out a what? Tangent. Does that help you? So when you got a little hint to get started, when we, woo. Okay. I think number 9's not as bad as it looks. Can we just make it equal 0? There's all cosines, right? So if we add a cosine squared over here, what do we have? How many cosine squareds do I have now? Yeah, except I like my to be positive. That's the only reason I went this way. That's a great question. It would have been easier to move that one over there. But by adding the cosine squareds here, I ended up with positive 4 cosine squareds, you know me and my positive squared term. So then I would also add 4x over to this side, or 4 cosine of x. and add the 1 over there so that I got it equal to 0. Anybody know how that one will factor? Remember, it's like a 4n squared plus 4n plus 1. Maybe 2n plus 1 and 2n plus 1. Does that work? So a 2 cosine. So what's the only thing cosine can be? -1/2. And we want only the answers from 0 to 2 pi. So I think there's 2 of them. 2 pi over 3 and 4 pi over 3. Any ideas on 10? What is the thing we can't do that someone might be tempted to do? I tried to make a big deal about, yeah, divide. Remember, we can't divide by a function. You can't divide a sign off both sides because you lose some of the solutions. I guess because I like my squared term to be positive, I would subtract it over that way. So I'd have 2 sine squared minus square root of 2 sine x. And then what would my next step be? I'm not going to finish it, but what could I take out of both of those? Yep. I'll let you finish. But that's the idea on that one. Antoine, you awake? Everybody good? Is that it? Or is there 2 more? Okay. Which one? Ugh, that looks messy. There's no squareds. It would be a little, you got to be careful because we need to add this over to the other side. If we add this over to the other side, we have a -2 square root of 3 cosine of x sine of x. When we add this over to the other side to get it equal to 0, can we add those? Are those like terms? No, because to be a like term, like this is like an x times a y. There's 2 separate functions there, and this is just x, so we can't add them. Okay, what can I take out though? Cosine, that leaves me a lovely -2 square roots of 3 sine of x plus what? We're dividing out the cosine, so it's +3. Everybody okay? We're not subtracting it, we're dividing it out. Okay, we're factoring it out. So now I have the cosine of x equals 0, or I think we're going to have to mess with this one. -2 square roots of 3 sine of x plus 3 equals 0. I'm going to just subtract the 3 to the other side quick. Ugh. And then I'm going to divide by -2 square roots of 3. What is happening here? Well, a negative divided by a negative becomes positive. There's a start. What else do we have to do? We were dividing, right? Okay, we divided, so we added or subtracted the 3 over there and got it was negative. And then when we divided by that, we got a positive. Okay. We just need to rationalize, right? Square root of 3 over square root of 3. But that is 3 square roots of 3 over what? A 2 times a 3, or this would be a total of 6. But now what can happen? Yeah, this reduces and we are left with square root of 3 over 2. That was really gross. Okay. Now you should be able to solve. Was this all solutions or 0 to 2 pi? 0 to 2 pi? So I think there's 2 places where this is true and 2 places where this is true. Is there 4 solutions? Cosine is 0. at pi over 2 and 3 pi over 2. And the sine is square root of 3 over 2, means we're looking for it back here. Is that a pi over 3? Okay, that was a great final question to do because it was ugly. Anybody, just what little hint could I give you for 12 maybe? That was the hint I don't want you to do. You can't take out a sign because there's a +1 back here. 3 terms, so we have to do what? 2 parenthesis things? Is that a good hint? Okay. I'm gonna be quiet and let you work on finishing those, okay?